To us human beings, absence of light means darkness. And when we can't see anything, we often assume there simply isn't anything. But what if we just don't have the right eyes to see what is out there? Thanks to its ability to detect radiation at far infrared and sub-millimeter wavelengths, the Herschel Space Observatory allowed us to unveil secrets of the cosmos that are invisible to other telescopes, revealing faces of the near and distant universe that so far had remained hidden. Herschel gave us the ability to see light that was always there, but we couldn't see before.
So my name is Göran Pilbratt. I'm the Herschel project scientist, and I've been working on Herschel since 1991.
My name is Erbe van Dishoek from Leiden University, and I've been associated with Herschel since 1982.
The far-infrared telescope in the late 70s, early 80s was seen as interesting because absolutely nothing, no observations had been done in this part of the spectrum because there were no equipment to do it. And this part of the spectrum is key to understanding several aspects of what's going on in the stellar medium, including how stars form, for instance.
Well, one of the dreams in the community at the time was really to understand how and where stars are formed and of what kind, low mass, high mass. For me as a chemist, the big question was really how molecules like water are produced in space and how we can follow sort of their trail from collapsing clouds to planetary systems. And then there was a whole other science case on the deep extragalactic universe. Can we resolve the far-infrared background into individual galaxies? And how do these dusty galaxies form and how do they evolve?
So in the spring of 1982, Thijs de Graaf organized a meeting where he collected people interested in this area and in order to prepare the writing of a proposal for a far-infrared telescope. And after the summer, this proposal was written and submitted. And this is how it all started.
In 1982, I was still a PhD student in astrochemistry, but I was invited to come to this meeting where all the big names in millimeter astronomy were present. And that is really where we developed the initial science case for Herschel. We realized that to advance our science, we needed to be able to peer into these dusty regions of the universe, where all the action is happening, where stars and planets are being formed, and where galaxies form and evolve.
Drafted in 1984, the Horizon 2000 plan was distilled from 77 proposals from the community for future space missions. However, only 2 of them entertained the idea of far-infrared astronomy. The mission later known as Herschel was one of them. This concept was very well received and was eventually selected as one of the 4 cornerstone missions of the program.
The Horizon 2000 program was composed of cornerstone missions and somewhat smaller, medium-sized missions. Herschel was so ambitious in scope and scale, there was never any chance of constraining it to the envelope of a medium mission, so it was an obvious choice for a cornerstone mission. It also was the first time we explored that long wavelength region of the electromagnetic spectrum from space in such detail, so it became an obvious choice.
Because it was built to be sensitive to the far infrared light, Herschel was able to see where humans and other telescopes were blind. To be able to perform the many different observations, astronomers wanted Herschel to be equipped with 3 different but complementary instruments: 2 imaging photometers and spectrometers, PAX and SPIRE, and 1 heterodyne spectrometer, HiFi. Keeping these instruments at extremely low and stable temperatures was critical to the success of the mission. The launch of a rocket is one of the most critical moments of a mission. So, as the product of many years' work prepared for takeoff, scientists held their breath, and hoped for the best.
It was the first launch the science program had had for a period of time, and there were two really exciting spacecraft, a large cornerstone mission, Herschel, and a so-called medium-sized mission, Planck, both of whom were going to do cutting-edge science. Also, putting two large missions like that together in the same launch vehicle, the same Ariane 5, was brave and a little bit frightening. We're all really sitting on the edge of our seats, fingers tightly crossed during the launch itself.
So there's a lot riding on it, and literally hundreds, maybe even thousands of people whose work for several years is tied up with this event being successful. And of course, as we know, they can fail.
Herschel's journey had finally started, and after separation from its launch partner Planck, Herschel made its way to its orbit around the Lagrange point 2, 4 times as far away from Earth as the Moon. Everything seemed to be working well at first, until an anomaly in Herschel's movement was detected. It seemed the entire spacecraft was wobbling.
When we tried for the first time the mode, which was intended to be used for the scientific measurements, we realized that the attitude control system was doing something unexpected. Instead of steering stably in one direction, it started oscillating. So it was going to the left, to the right, to the left, to the right, with a period of about 1.5 minutes, and indeed with an amplitude 10 times higher than expected and 10 times higher than needed for good scientific measurements. Finally, we found the source of the problem, which was a heater close by, which caused either electromagnetic interference or thermal disturbances. We are not sure about that. And so the problem could be solved in that way. So luckily, we were able to cure the problem really such that there was no impact at all. And if we would not have found the source of the problem, then we would have continued investigating. We would have thought about software patches, about offline processing. We would never give up.
Well, I guess when people have worked for a long time, over years, and done many, many tests, because we do tests all the time, to be ready to deal with problems, well then when a problem occurs, it's the moment when you get to fulfill all the preparations you've done, and you get to see the system, this very complex system, working like a well-oiled machine. And that's the most rewarding experience you can have.
With the cryo cover on, the instruments could not see the sky. On the 14th of June 2009, exactly 1 month after launch, the command was uplinked for the cryo cover to open, and Herschel finally opened his eyes for the first time.
The cryo cover opening was a critical event. It was a potential single-point failure, just like the launch. But it was different because it was opened by manual commanding. So 8 seconds after the command was sent, we could see on the screens that something was happening. And everybody went jubilant. Wow, yes, it was done.
After the lid was opened for the first time, the scientists were eager to see what Herschel was capable of. They pointed it on the so-called Whirlpool Galaxy M51, and after some tense waiting, they received the first image.
The first light image of the spy photometer, it's an image of a nearby galaxy, and you had all this what looked like noise in the background, until somebody realized this is not noise. This is the high redshift universe at the same time. It was just crazy.
When the first image popped out on our screen, it was a fantastic moment. We were cheering, we were hugging each other. It was a lifetime moment, and such a relief, of course. The first thing I did was to check the image quality, the PSF, the point strength function, and it was just what we expected, like in the textbook. So we knew we had a mission, and we could start it.
But that initial joy wouldn't last long. On the 2nd of August 2009, right after the end of the daily telecommunication period, something unexpected happened. It was clear that an important problem was affecting Hi-Fi, forcing operators to switch it off temporarily. But a long delay could turn out to be extremely critical for Herschel, since the liquid helium that served as coolant was only planned to cover 3.5 years of operations in space.
In August 2009, we discovered that the hi-fi instrument was not working any longer. This is what we now call the hi-fi anomaly. The hi-fi anomaly could only be solved by employing all the kinds of knowledge that was available in the world. So we had 35 people coming from very different space agencies that helped us do the crime scene investigation. And in the end, we were able to pin it down to one diode that broke down in a power unit. After that, we made new procedures, and we used the second copy of hi-fi on board of Herschel in order to do the rest of the observations, and it did so successfully until the end of mission. It was a great relief because the investigation had been very tense for me, but also for the whole team. And it was great to see that the results were coming in again, and that the whole astrophysical community could use hi-fi again. So in the end, I was very, very much relieved.
By spring 2013, Herschel was getting close to exhausting its supply of liquid helium coolant. The last data taken by Herschel before helium depletion was a hi-fi spectrum of a dying star. The spacecraft controllers made sure that Herschel was put in a safe orbit around the Sun, and only then the last command was uplinked to the spacecraft on the 17th of June, ending almost 4 years of pioneering observations of our universe and providing us with a treasure trove that will keep scientists busy for many years to come.
The very last command to Herschel was in fact the end of a sequence of commands where we slowly shut down all the systems one by one, and in the end we switched off the communication system so it could not talk to us anymore. So sending the last command was a mixture of sadness and achievement. Massive sadness because it was saying farewell to a spacecraft that had performed magnificently, and achievement because yet another milestone ticked off in the 35-year voyage of Herschel.
Herschel made over 35,000 scientific observations and amassed more than 25,000 hours worth of scientific data. All of these unique far-infrared observations, publicly available from the Herschel Science Archive, gave astronomers new insights into how stars and galaxies are formed and allowed them to trace water through the universe, from molecular clouds to newborn stars and comets. Herschel's observations also revived the idea that our planet's oceans could once have originated from space. Although the Herschel mission has now reached retirement, the legacy of this remarkable mission carries on, and it will remain a primary reference for astronomers for many years to come. Now it is up to the next generation of researchers to pick up this legacy and make new discoveries.
So the work I've done with Herschel had a really high impact in my field, and right now every project I start, I really take advantage of the fact that I know the data well, I know the archive, and I quickly can go and grab the data I need, the information I need, and get that panchromatic view of the objects I'm studying, young stellar objects. And what Herschel could contribute, knowing how these disks, what are the properties, and if they are really able to develop planets, I think those results were revolutionary.
For me, the most fascinating part was discovering objects that have never been seen before. The far infrared is a very good way of discovering high redshift galaxies, and although we follow them up to find more information with other telescopes, Herschel was very efficient and good at finding these objects in the first place, and just seeing something that has never been seen before was amazing. But to answer the next question, which is the physical processes that create these galaxies and transform them into what we see in the nearby universe, we need more sensitive telescopes and larger telescopes, new space telescopes, to really delve into the characteristics and processes of these galaxies.
So many exciting results. Herschel has really lived up to its expectation. And therefore, thank you, Herschel, from the bottom of my heart, for making all our wishes come true, and so much more.
Tack för allt du har gjort för oss, Herschel.
Thank you, Herschel.
Hartelijk dank, Herschel.
Благодаря, Herschel.
Gracias, Herschel. Merci, Herschel.
Danke, Herschel.
Thank you, Herschel.
Dank u wel, Herschel.